Today is the 22nd of September 2023, and we would like to look at functions. Okay. Before I introduce today's lesson, thank you to everyone who has been watching our videos. Okay. If you've benefited from it, can you considering subscribing, sharing, liking, and following us? Okay. And I would really appreciate that. I normally write in the comment section, please follow my notes/scripts. Okay. This is less than, that is greater than. Okay. So if this is what we are solving and you hear or maybe I'm pointing here, this is less than or equal to, and you only hear less than, the chances are it's less than or equal to. Okay. So in that case, follow the notes. Okay. I'll really use your help on that. Okay. Beware of scammers. Okay. They are everywhere. They'll send you an email in the name of, they are doing everything possible. Okay. Just if you're online, be careful. Okay. If somebody asks you for donation or money or with foreign numbers, please don't, because the chances are, if they get hold of your account, they will take everything out. Okay. So don't fall for these people. Our recap for today, okay, it's from last lesson. We've been looking at inequalities. Okay. And we said less than, greater than, less than or equal to, greater than or equal to. And I even said this less than sign looks like a slanted L. So immediately I figured that out. This was like less than, so L, less than. And then the other one is greater than. So this and this, less than, less than, less than or equal to, greater than or equal to. You can also figure a way out of differentiating. Okay. But that is what I found to be useful for me. So I still remember it to this day. Now, when you find your answer in the inequality, you use open and closed circles to represent it. So for instance, if it's less than or greater than, you use an open circle. If it's less than or equal to or greater than or equal to, you use an open circle. So a closed circle is like that, and an open circle, okay, an open circle is like that, and a closed circle, this is a symbol for the closed circle. Okay. That's a closed circle. You shade the circle in between. So that's open and that's closed. Okay. So you can watch yesterday's video and the videos we did earlier on. I think we did a little bit of inequality. So you can use that as well. Okay. So we solved inequality and we represented them on the number line. Okay. And then there was a rule: when we multiply or divide an inequality by a negative number, okay, the sign also flips from less than to greater than, or less than to greater than. So for instance, if you have minus x is less than 8, then x will become greater than minus 8, because we are going to multiply by minus 1. So that's one of the rules that we saw. Okay, so immediately you multiply or divide by a negative number, your sign also flips. Okay, we learned that yesterday. Now, so let's look at what we an example from yesterday. So we have 9x plus 5 equals 4x plus 25. Okay, so now we put the x's to one side and the numbers to one side. Because of the equal to sign, this is an equation. So straight away, 9x, when we bring 4x to this side, it becomes minus 4x. So we have 5x. 25, when we bring the positive 5 to this side, it becomes minus 5. So 5x equals 20. X equals 4. Okay. But this is not an inequality. What it just tells us that when we put x 4 back into the equation, okay, 9x plus 5 will be equal to 4x plus 25. Now the same equation, we are going, instead of the equal to sign, we are going to replace it by greater than. Okay, so we are going to solve the inequality and represent it on the number line. Now this is greater than, so our final answer will become x equals greater than something. Now because it's greater than, we will have to use an open circle. Okay, now 9x plus 5 is greater than 4x plus 25. So if we bring 4x to the other side, or we subtract 4x from each side, we have 9x minus 4x, which will be 5x. 25 minus 5, which will be 20. Now 5x is greater than 20. When we divide both sides by positive 5, then x will be greater than 4. Now straight away we know we need an open circle. So this is our number line. X is greater than 4, so that's the open circle. That is 4, so the arrow will go that way because it's x is greater than 4. So this is what we've been doing so far from last lesson. Now I started today. Okay, y equals x plus 1. Okay, find y when x is 0. 1, 2, 3, 4, and fill the table. So we have x and y. When x is 0, okay, 0 plus 5 will be 5. When x is 1, 1 plus 5 will be 6. When x is 2, 2 plus 5 will be 7. When x is 3, 3 plus 5 will be 8. And when x is 4, 4 plus 5 will be 9. Okay, so I've managed to do it here, and I've filled the table. Okay, as I've just talked you through. It's a simple equation. Okay, x is 0 to 1, F4. We put x there and we find y. And we fill the table. Basically, you can have this question in Gcse. Okay, the foundation paper, some of the questions are very easy. So you can have a question like this. Okay. Now, today we want to discuss function. So we normally have, like what we just had in the starter, y equals x minus 7. Okay. So when x is 8, what will y be? So you put x there, 8 minus 7, y will be 1. Okay. If you are doing coordinates, then you go ahead and plot. But this is not what we are being asked to do. We are just finding the values of y when x is something. Okay. When x is 9, 9 minus 7, y will be equal to 2. Okay. If we replace y equals f of x, okay, so this is where the function name comes from. Now, we are not dealing with y, we are dealing with functions, okay. The f of x means here is a function when x is like 9, and y will be when y is 2, x is 9. Okay, so the f of x means maybe the output. So you have a big machine, you put something in, and then it brings out something. Okay, so if we replace y equals f of x, then we have when f of 8, okay, s is 8, what will y be? So 8 minus 7, y will be 1. When x is 10, so f of x, f of 10, 10 minus 7 is 3. Okay, when f of 20, so x is 20, so in place of x we put 20. 20 minus 7 will be 30. So in mathematics, functions by f of x instead of y. So if we are talking about function, we don't write y equals, we write f of x equals. So if we know the value of x, then we can find the function. I hope I've made sense. Okay. Imagine it as a machine. You are putting in x on one end, and then on the other end, the function operates on it, depending on what formula is operating on. So maybe if you put 1, the function is x plus 1. So it adds another 1 and gives you 2. Okay. Now let's get on. So a function f of x may be looked at as a machine, as I've just told you. So let's look at an example. Okay, f of x equals 2x plus 7. Okay, so when we input x equals 3, f of 3 now, okay, we input 3 into the machine. F of 3 now will be 2 times 3, which is 6, plus 7, which is 13. So we input 3 under this rule of the function 2x plus 7, we get 13. Okay, so the input here is 3, the output is 13. Okay, and the operation that the machine is working under is 2x plus 7. Now another example. Consider the function 15x plus 3. Okay, find the function when x is 2. Okay, so when x is 2, f of 2, okay, you put in 2, 30, because 15 times 2 is 30, plus 3, so f of 2 becomes 33. When x is 5, okay, your input is 5, so 15 times 5, okay, which is 75, add 3, which is 78. So you input 5, you get 78. When x is 8, so you are going to put in 8, and you expect an output under this operation. So 15 times 8 plus 3, which will give you 123. Okay, and so when x, the input is 8, the output under this operation 15x plus 3 will give you 123. So as I've just explained to you, we input x equals 2, we output f of 2, 33. Under this operation 15x plus 3, we input x equals 5, our output becomes f of 5, 78. We input x equals 8, our output becomes f of 8, 123. Let's look at another example. So the operation here is 5x plus 11. Okay, so here we don't know x, but we've been given the output when f of x is 16. Okay, so we need to find our input. So this is our output, that is the operation here. Okay, we've done a lot of algebra, so this should be easy by now. Okay, that's the purpose of doing all those stuff we did in the beginning. Okay, so now f of the output is 16, so 16 equals 5x plus 11. Now if we move plus 11 to that side, it becomes minus 11. So 16 minus 11 will be equal to 5x. So 16 minus 11 is 5 equals 5x. So x equals 1. So it means our output 16, we need an input x equals 1. So what he's saying is to get an output of under this operation here, 5x plus 11, you need of 16 an output, you need to put x equals 1. Now let's look at another one. Okay, now our output here again is 26. So 26 equals 5x plus 11. 26 minus 11 equals 5x. So 26 minus 11, 15 equals 5x. Okay, 15 divided by 5 equals x. X equals 3. This type of question should be careful. Remember yesterday, this inequality, I think 2x greater or less than 16 minus some 2x, and I wrote x equals 16. Okay, so I gave you a wrong denotation on the number line when x was greater or less than x, and because there was a minus sign, the sign had to flip. So even though you are following the method, you need to be careful, because you might just get the answer wrong if you don't do this step right. Okay, so you might gain marks for these steps, but you might not gain your 1 mark or 2 marks, okay, for your answer because you gave a wrong answer. The examiner knows, or whoever is marking your work knows, that you know what you are doing, but the fact that you were not careful and you got the answer wrong, they are not going to give you the full marks, sadly. So you need to be very careful. When I'm preparing this note, I put everything off. I work like I'm in an exam room, okay, and then I go over and over again. But sadly, like yesterday, I didn't skip that. That's why I keep on saying follow my notes like script, because as I'm presenting it to you, if there is any mistake, I'll correct it. Okay, I might not edit it, I might just put it out there. Okay, so these are some of the simple things you can do to lose marks, so just be careful. Okay, so now x equals 3. So they've given us an output of 26. We found out that if you have an input of 3 and you put it in this function here, 5x plus 11, you get an output of 26. An input of 3 will give you an output of 26. Okay, so the x is your input and the f of x is your output. Okay, and the equation here, okay, 5x plus 11 is your operation or your function. Okay, now how can you use this in real life? You can use it for like conversions. Okay, so for instance, if you are changing pounds to euros or dollars or any other currency, okay, and you go to the shop, they have the convention sign there. So whatever you have is your X, okay. Whatever the rate is for that day is your operation or function, and whatever money it is converted into is your output. So if you go to the forex changing machine and you give them £50 and you want euros, and for instance they give you, according to today's rate, they give you 62 euros. 62 euros is your output. Their conversion, okay, or the national rate is your operation, and your £50 that you gave them is your X, okay. So that is one of the uses. Now weight, so you can change kilograms to pounds or pounds to kilograms. So for instance, in some part of the world, if you give birth, they give you the weight in kilograms, okay. But some part also, they give it to you in pounds, okay. So you can say, you can convert it, okay. I'm familiar with kilograms, like 4.1 kilograms, 3.9 kilograms. So if I want to know the equivalent weight of a newborn baby, and they've given me it in pounds, okay, as in weight, not in money, then I have to use the conversion, the standard conversion. So that's another use. Now height, okay, height can be in meters, okay. So if for instance you are in meters or in centimeters, you can also change it to feet, or how many feet. Maybe you are 6'1", 5'9", but if you are maybe 159 meters or centimeters, then you can convert it into the appropriate feet, okay. Or if they've given it to you in feet, like 5'9" or 5'7" or 6'1", then you can convert it to the actual meters or centimeters. Now another one is a temperature, Celsius and Fahrenheit, okay. We normally get our temperature here in Celsius, but some countries might use Fahrenheit. So if maybe you've traveled and the weather is being calculated in Fahrenheit, you can use the conversion formula, which will be your operation, to find out what will it be in Celsius, okay. Sadly, some of these things, when in the 80s you didn't have a phone, so you couldn't do these things quickly, get it quickly. But now you have a phone, so you can just find a conversion table, put in what you want, and it will just convert it for you like that, okay. So that is one of the genius of the phone, okay. But these are some of the uses. So today we've been looking at functions, okay. We started our lesson recapping on inequalities: less than, greater than, less than or equal to, greater than or equal to. We talked about the open circle for less than and greater than, and the use of closed circle for less than or equal to or greater than or equal to, okay. We've gone on to solve an equation which involves the equal to sign, And then we did an example, the same equation we replaced by a greater than, got our answer, plotted it on a number line. Okay, then we did a quick starter with an equation. We knew what y is, so we substituted x, and then we tabulated whatever we got. So we used this equation to find a y when we've been given x. Okay, that is a simple equation. Somebody in year 6 should be able to do that. Okay, so and today we have looked at functions. Okay, what we put in and what we get out, and we said we denote our function by f of x. So if x is 1, then f of 1 will be what? So x is the output. So we've seen an example where we have an input, we find the output, and we also found seen an example where we've been given the output and then we find the input, and we've looked at some of the uses like conversion of money and stuff. Okay, so thank you very much for watching today's lesson. I really appreciate it. Okay, and I'll see you in the next.